So today we're here to talk about things that make code hard to test. Things like databases and networks and time zones and parallelism and other meanings of time and all those things. But generally, all of those really come down to one core problem. The thing that makes code hard to test is conflation of concerns. When you've got a piece of code that is mixing up multiple things, like how the execution path is going to happen, the parallelism, with other concerns, like the logic that I want to have happen, then it becomes very difficult to test each of those two. Suddenly, everything that tests one has to do it in the context of all the variations that can happen in the other. Right. So the obvious solution to this is separate concerns. Right. The problem is that we can't because, hey, I work entirely in legacy code. Yeah. Anyway, legacy code, it's untestable by definition. Right? You never are working in nice, testable, wonderful, fun code. If you were, you wouldn't need to listen to these videos. So in lazy code, we can't separate concerns because we can't test. So the usual solution that people do at that point is one of two things. They either test it together. They do some sort of integration test where we're going to verify the things in the context of the other one, and it becomes problematic because of all the multiple possibilities. Or they use seams and fakes. And they pretend the code was as separated as they would like it to be, and they fake out one side while doing the other side. The problem with those both solutions is they really lock in the existing conflation of concerns, right? Because now anytime that I would like to change my code, I would like to separate those concerns, I run into my tests as a problem. Right? If I'm testing things together, then as soon as I start separating one concern out, the test starts failing for unrelated reasons. Right? And if I use seams and fakes, then as soon as I start separating a concern out, A, I've got no test coverage, and B, I start having to update all of these mocks and fakes and expectations and stuff all over the place. Right? Again, tests fail for unrelated reasons, or they don't fail when they should. Right? So I don't want to go down that path. It doesn't lead to good places, which brings us back to the obvious solution, right? If only I could break out the concerns, if I could separate them. The problem is there is no general solution for that. Sorry. But fortunately, there are specific solutions to that, right? So there's a whole bunch of different ones. Depending on your specific problem, there is a specific solution for it. And if you look down below, I've got a number of them identified. You know, if you're sharing data, or if you've got a database, or if you've got time zones, or if you whatever it is, right? So there are a bunch of examples down below. But I want to just talk about one right now as a common case, one that I was working on a while ago. So I was working on a system that had a document. Now, a document seems like a beautiful abstraction in a document editing piece of software. It's an obvious domain object. It's wonderful until it's terrible because it's a God class and it results in universal data coupling. Anything that anybody wants to do suddenly has to touch this freaking document. And anytime that anyone wants to display anything touches the freaking document. All conditionals reference the document, right? It becomes a total mess, right? And it makes it so that unfortunately all of our code is a total mess. Like any change that we want to make starts interacting with any other code that's there. Right? It becomes impossible to test for correctness. So what do? Well, in this case, the approach that we did was we started to break apart all of the things that just refer to the document. They might do conditional logic, they might do reads, they refer to and use information from the document. And then there are the ones that modify the document, right? So there's sort of accessors and updaters. Right? And you start just teasing those out, extract a lot of methods, extract small methods, extract just little core components. And you start looking at sections of the code and what they need, right? And then you start isolating those in a couple of different ways. First, the ones that are just accessing the document, instead of accessing the document directly, they never need the whole thing. Give them loaders, right? A loader refers to the whole document and extracts out the core piece of information that some subsystem is going to need. It simplifies it. It provides the aspect that a code needs, right? And then puts that in a data transfer object. And now you can have all those accessors be pure functions. They simply take that nice, simple data transfer object. They do some stuff and give some answers to something else, right? And that makes them wonderfully easy to test, right? And then you've got the update sections, the updaters, right? So for there, we actually created an updater. It's like a builder pattern, right? So that code is going to read and stuff. And instead of taking actions that modify the document, it creates an updater in some particular state and says, I would like to perform the following update, right? And then that update can be scheduled, right? And so there's a scheduling loop that applies updates, right? And suddenly now I'm able to tease apart that gnarly mess of intertwined updates and reads and stuff into a sequence of creating updaters, operating with a document that's in a known state, and then applying some updates, and then starting to operate with a document that's a new known state. And suddenly everything's easy to test. There's code that creates updaters. There's updaters that changes the document. And there's code that reads the document and uses it via loaders, right? And each part is nice and easy to test. As we look down below, every single one of these, we see the same pattern over and over. First, we're going to extract and isolate a lot of extract methods, like we did with both the change, the updates, and the reads, right? And then following that, we're going to start doing various refactorings to alter the code sequencing, right? So we first isolate the chunks, then we bring those chunks together, and then we start altering the sequencing to make it more predictable and truly separate the concerns. Okay, so wonderful, except it seems like we're going to introduce a ton of bugs along the way, right? So how do we not introduce all those bugs? Well, there the approach is disciplined refactoring, right? So when we talk about refactoring here, I mean the real meaning of refactoring, right? Disciplined, bug for bug, verified by static analysis, right? So we do most of our changes via those strong, tight, disciplined refactoring so that we have a very small number where we're, for example, changing the sequencing that are not disciplined, that really we are making a change to the code and we need to analyze and test it, right? And that dramatically reduces the scope of our test. Now all of our testing is to make very intense focus on places where we're intending to refactor, we're actually remodeling, right? But we're intending to make a safe change, and we just need to verify that it is safe. And it's one tiny change to the ordering of a couple of different things, right? Everything else, fully disciplined. Now, if you want to know more about how we do those disciplined refactorings, how we do the remodeling, how we make the whole process safe, please join us in an Ask Me Anything. We have regular Ask Me Anythings to talk about all this stuff in legacy code and share many, many stories. The sign up is below. And in the meantime, I hope that the article below gives you many designs that you can use in legacy code to fix the most common problems.